everyone, welcome back to another lesson of number sequences. Today we are going to be investigating arithmetic sequences. Before we look at our concept map today, I'm going to ask you a question. Have you ever thought about patterns that occur in real life? Maybe there's something that happens at regular intervals, or maybe you see that certain prices of things increase at a certain rate. Patterns are everywhere, and today we are going to be focusing on arithmetic sequences. Let's have a look at our concept map. So, I have discussed this in previous lessons, but in case this is your first time with us today, we have discussed that arithmetic sequences have a common difference. So this is the property of an arithmetic sequence. Firstly, I'm going to be talking to you about the general form of an arithmetic sequence, which is Tn is equal to A plus n minus 1 d. Just a note to remember that A is representative of the first term of a particular pattern, and D is the common difference. Before we look at an example, I'm just going to go over some important definitions that are important for you to have at the back of your minds as we go through this section. Please remember that a term number refers to the position of the term in a sequence. Tn is the nth term of the pattern, where n is the term number. So for instance, if I say T1 is the first term of the pattern, T1 is the first term because n is equal to 1. T3, where we can see that n is 3 because of that subscript, T3 is the third term of the pattern. As I've already mentioned to you guys, n is 3. So just a reminder, the n refers to the term number. Then we move on to the definition of term value. Term value refers to the actual value of the terms. This is not the term number. This is the actual value of this term. So if I say T7 is equal to 334, I hope that everyone's with me, that means that the seventh term has an actual value of 334. The term number is 7 because it's in the seventh position of the sequence, but the value of the seventh term is 334. Please make sure you're comfortable with the differences between term value and term number. Let's look at the next slide. So we've already mentioned common difference, but please just remember that the common or constant difference is the difference between any two consecutive terms in a linear sequence. So if I give you the pattern 2, 4, 6, 8, 10, we can see that we have a constant difference of positive 2 between the consecutive terms, and because I have that constant difference, it is a linear pattern or a linear sequence, but we can also call this an arithmetic sequence. Okay, the next definition, everyone, is the general term. The general term is a mathematical expression that describes the sequence and that generates any term in the pattern by substituting different values for n. So, this means that the general term is a mathematical rule where I can substitute in n values or term values. So if I'm substituting in term numbers, I will be able to determine the actual value of that term. Or alternatively, you could be substituting in a term value to determine which term actually has a value that is given to you. So let's have a look at the next slide. So we've discussed that a common difference is present in arithmetic and linear sequences. Now I'm going to write down how we can actually determine the common difference. The main way that we do this is we often say that the difference is equal to term 2 minus term 1. And we normally check to see whether this common difference is correct by then doing term 3 minus term 2. But in general, we can define the common difference to be that the common difference, d, is equal to t n minus t n minus 1. What this means, everyone, is the common difference can be calculated for a linear sequence by taking the value of a term and subtracting the value of the term that comes before it. So I'm going to say that again for everyone. The common difference can be found by taking the value of a term and subtracting the value of the term that comes before it. Let's have a look at the next slide. So we are now going to generate an arithmetic sequence. We've already discussed that T1 is equal to A. If I'm looking at term 2, I'm sure everyone will agree with me, that's going to be A plus D, because it's A plus 1 difference. So, I actually don't need that other equal sign over there. If I'm looking at term 3, it's going to be A plus 2 differences, because I have now said it's A plus a difference plus another difference. Term 4 will be A plus 3 differences. Term 5 will be A plus 4 differences. So we can see that if we link it back to term 1, there were no differences added for term 1. Then moving down, I added 1 difference, then 2 differences, then 3 differences, then 4 differences, and this pattern will continue going on. So that's why I can say that the general term is equal to A plus n minus 1 D. So for term 4, we added 3 differences. For term 5, we added 4 differences. For term 3, we added 2 differences. So because of this pattern, we can then say that as we know that the general form of an arithmetic sequence is equal to A plus n minus 1 D, I can actually write down the formula for any term with any term number. So term 32 would be equal to A plus n minus 1, and in this case, n is 32. So it's going to be 32 minus 1d. So term 32 will be equal to A plus 31d. And this is going to help me because I can actually skip this step moving forward. Because I could say that term 15 is equal to A plus 14d. I'm hoping that everyone can see that the coefficient of the d is always 1 less than the term value. So term 16 will be A plus 15d. Term 20 will be A plus 19d. After the break, we're going to look at some more examples of arithmetic sequences and how the formula behind me can help me. Welcome back, everyone. We're going to be continuing our lesson on arithmetic sequences. Before the break, I had just derived the formula that we use for arithmetic or linear sequences, but now we're going to be going into an example where we can apply this specific formula. Let's have a look at the board to see our example. So we are asked to consider the sequence 10, 4, -2, -8. We've been asked a few questions on this sequence, so let's have a read through them. Firstly, we've been asked what is the common difference. We then asked to state the values of the next 2 terms in the sequence. C is asking me to determine a formula for the nth term of the sequence. D is asking me to determine the value of the 20th term. And E is asking if 40 is a term in the sequence, and we're going to justify why it is or why it is not. So let's first consider the sequence. I'm going to write it down for us because we need to determine the common difference. I'm going to give everyone a second at home to think about it. We need to know what the common differences between these terms are. So, between 10 and 4, I can see that I subtracted 6. Then, to get from 4 to negative 2, I subtracted negative 6 again. Then, to get from negative 2 to negative 8, I subtracted 6 again. So this means that the common difference is in fact negative 6. Cool, let's move to question B. So we now need to state the values of the next two terms in the sequence. Great, so we've established that the common difference is negative 6. So in order to actually determine the value of the next two terms, I'm going to have to subtract 2 from the last term given, and then subtract 6 again. Sorry, I said subtract 2, I meant subtract 6. So we're subtracting 6, and then subtracting 6 again. Let's go to the board. So I'm going to subtract 6 over here. Negative 8 minus 6 will give me negative 14. Then I'm going to subtract 6 again, which is going to give me negative 20. So the next two terms of the sequence are negative 14 and negative 20. Right, the next question is asking me to determine a general form for the sequence. We know that the general formula for an arithmetic sequence is Tn is equal to A plus n minus 1 d. We know that A is the value of the first term and d is the common difference. Let's write it down and actually determine this formula together. So we said that Tn is equal to A plus n minus 1 d. What is A? I'm hoping that everyone will agree with me that A is equal to 10. Why is A 10? We know that A is the first term. Great. Then what is D? We discussed on the previous slide that D is equal to negative 6. So when determining Tn, I'm going to have 10 plus n minus 1 times negative 6. So hopefully everyone can see that all I've done is I've substituted in a value for A, which is 10. Then I've substituted in a value for D, which is negative 6. I'm now going to simplify. So I'm going to have Tn is equal to 10 minus 6n plus 6. Simplifying that one step further, the general term will be equal to 16 minus 6n. So that is the general term for my arithmetic sequence. Now that we have our general term for our arithmetic sequence, we are going to be able to either substitute in n values to determine the actual values of certain parts of the pattern. Alternatively, we can substitute in Tn values. Tn values are actual values that could occur in the pattern, and by substituting in Tn, we can actually find values for n, which refer to the positions. Let's have a look at the next question together. So, we have been asked to determine the value of the 20th term. We are asked for the 20th term. We are not asked which term is equal to 20. 20 is then going to be my n value that I am going to substitute in. So I'm going to have T20 is equal to 16 minus 6 times 20. So guys, I hope that everyone's happy with what I've done. I've used the subscript of n being 20, and I've substituted n is equal to 20 in order to find the value of the 20th term. So simplifying, term 20 will be equal to 16 minus 120. And if I simplify this further, I'm going to see that term 20 is equal to negative 104. For this specific example, I substituted in n is equal to 20 to solve for the value of the 20th term. I can see that the value of the 20th term, as you can see behind me, is negative 104. Let us move on to the next part of the question. We have been asked, is 40 a term in the sequence? We need to justify our answer why it is or why it isn't. When I'm asked, is 40 a term in the actual sequence? What this is asking me is this Tn value, because I know when I substitute n for Tn, I'm substituting a number n. So I'm actually going to substitute in 40 for Tn is equal to 16 minus 6n. Something that I do want to point out to everyone is I'm asked, is this a term in my actual sequence? So the fact that the question is actually asking me, is it actually going to be a term, should get some of our cogs turning in our heads, because this is actually kind of hinting at us that there is the possibility that it's not a term in our sequence. But why would it not be a term in our sequence? What are the possible conditions? I just want to point out to everyone that we have to remember for n values, it has to be a natural number. Please remember that natural numbers start at 1 and they go up. So it goes 1, 2, 3, 4, going the whole way up. Natural numbers do not include fractions. They do not include negative values or irrational numbers. They are whole numbers. We know this because I want to be able to determine term 2 of a pattern or term 100 of a pattern. I never have a situation where I say I want term negative 112 of a pattern or term negative a half of a pattern. It always has to be a whole number. So that's already telling me my whole goal for this question is to see if n is an actual whole number. If it's not a whole number, that means that 40 is not a term in the sequence. Let's look at the board to see if it works. So I've substituted in 40 for Tn. So it's going to be subtracted by 16 because I'm going to carry the 16 over. So it's going to be 24 is equal to negative 6n. Then if I divide both sides by negative 6, I'm going to get that n is equal to negative 4. So this has posed a problem to us. We can't find the negative 4th part of a pattern. Terms are whole numbers. So if it was term 4 was 40, then it would be acceptable. But because n is equal to negative 4, that means that 40 is not a part of this pattern. So let's conclude on the board together. So we're going to say, but n cannot be equal to negative 4, therefore 40 is not a term in the pattern. Cool. So everyone, what I'm going to do now for the last few minutes of the lesson is I'm going to discuss what I've covered. We have covered that arithmetic sequences have a common difference. Please remember that this is the main property of an arithmetic sequence, and this property can help me with finding general terms and answering specific questions with arithmetic sequences. We then discussed that the general form of an arithmetic sequence is Tn is equal to A plus n minus 1d. I'm going to write on the concept map behind me just to give us a few more ideas of what we've covered in this lesson, so also you can write a bit of a summary for yourself. So, we discussed that the common difference can be written as Tn minus Tn minus 1, because we know that the actual value of a term minus the value of the term that comes before that is the common difference. If I'm looking down at the general term, we discussed that A is the value of the first term, and we discussed that D refers to my common difference. Cool. The last thing that we discussed is we actually discussed the general term and how it can actually help me write other terms in terms of their differences. So we discussed that if I were to write term 7, this would be equal to A plus n minus 1d. I would substitute in the 7 for the n, which would leave me with A plus 6d. But I can actually skip those steps. I can go straight from T7 to A plus 6d. If I asked you for term 11, I could actually skip straight to writing A plus 10d, because I've subtracted 1 from the n number. Cool, guys. So please remember that with the general term, we can substitute in Tn values as well as n values. If I substitute in Tn values, I'm often looking for the n. So please remember that Tn is actual values and n is term numbers. Great. Hopefully this has helped you have a bit more of a background understanding on arithmetic sequences, and if you tune in again sometime soon, you'll see more practice. Great, guys. So now that we've discussed different parts of the arithmetic sequence, we're going to go to an ad break, and as soon as we're back, we're going to dive into some more examples. See you soon. Great, everyone. So now we are going to be focusing on more calculations with arithmetic sequences. For this portion of the lesson, I'm going to be focusing on how we can calculate A, D, Tn, and n. Let us have a look at our example. So we have been asked to determine the sequence, and when I'm asked for the sequence, that means I'm asked for the first 3 terms of the arithmetic sequence. Arithmetic sequence means that I know that I have a common difference. We are told that the 5th term is 16 and that the 9th term is 28. This one is slightly different to what I've done in the past. Why? Because A and D are not obvious. So we are going to have to rely on our knowledge of the general form of an arithmetic sequence in order to solve for this question. Please turn back to the board with me. So we've been told that T5 is 16 and that the 9th term is 28. I'm going to replace T5 with A plus 4D. This is stemming from my general form of an arithmetic sequence where I know that it is always A plus the term number minus 1D. So I've replaced term 5 with A plus 4D, and I'm going to replace T9 with A plus 8D. Everyone, we've now seen that we have an A and a D. what do we normally have to do when I have two variables that are unknowns? I'm hoping that you're saying simultaneous equation. So we are going to solve for A and D. Let's go back to the board. So I am going to isolate A on this side of the board. So I'm going to have A is equal to 16 minus 4D. I'm then going to substitute this across over here. So what I have for my value of A, I'm going to substitute in for this A. So I'm going to have 16 minus 4D. All I've done is replace the A with what I isolated A to be, plus 8D is equal to 28. So I'm going to have that 4D is equal to 12, which means that D is equal to 3. Now that I've found a value for D, I'm going to take my D value and substitute it back, and I'm going to replace the D over here. So A is equal to 16 minus 4 times 3, which means that A is equal to 16 minus 12. Hopefully everyone will agree with me that that means that A is equal to 4. So what I've done is a simultaneous equation where I have solved for A and D. I first isolated my A, and then I isolated my D and took it back to solve for A. So Tn will be equal to A plus n minus 1D. And I've now found my A to be 4, and I know that my D is 3. So if I simplify that, I'm going to have Tn is equal to 4 plus 3n minus 3, which means that Tn is equal to 3n plus 1. I'm hoping that everyone's with me at this point. So essentially, what has happened in the example behind me? I was given two different pieces of information about a pattern. I use those pieces of information to express certain terms in terms of A and in terms of D. I then solved simultaneously for A and D. Once I had A and once I had D, I could then substitute it into my general formula to isolate the general term. So let's look at the next part of the question. The general term is Tn is equal to 1 plus 3n. The question asked me to determine the sequence, and determining the sequence means that I've been asked to determine the first 3 terms. And if I'm determining the first 3 terms, I'm going to be substituting in n is equal to 1 to find T1, n is equal to 2 to find T2, and n is equal to 3 to find term 3. So term 1, please remember that when I'm replacing n, I'm substituting in for here. So I've stated the n value that I'm substituting, and I'm substituting into n where the coefficient of that n is 3. So I'm going to have 1 plus 3 times 1, so that means term 1's value is 4. Then for term 2, I'm going to have 1 plus 3 times 2, because I'm substituting in 2 for n, which is going to give me 7. Then for term 3, I'm going to substitute in 1 plus 3 times 3, why? Because n is 3, which is going to give me 10. So my sequence is 4, 7, 10. Great. I'm hoping that everyone's with me and everyone's fine and following. We're going to be going to an ad break shortly, but please hang on for me. We're going to be doing some more examples after the break. See you soon. Welcome back from the break, everyone. We're now going to be continuing some more examples with regards to finding the values of a, d, tn, and n for arithmetic sequences. Let's have a look at our next example together. So we are given the arithmetic sequence 2x plus 4 minus 2x minus 3 and 3x minus 1. Before I go any further, I don't want you to worry. Yes, there are x's. Yes, there hopefully aren't your x's on my board because that would be awkward. But we are going to use your favorite, algebra, in order to work out this question. So before your brain goes, oh, no, can't do this, they're x's, let's see what's actually being asked of us and why there are x's in my actual sequence. Let's go back to the board. So we are going to determine the value of x for which these terms form an arithmetic sequence. So we're going to handle the x's first things first. So don't worry, we're going to get rid of those x's before you know it. Then B is asking me to determine the formula for the nth term of the sequence. Then C is asking me for the value of the 11th term. So going into the part of the example where I need to solve for x. I've been given 3 terms of my pattern which involve expressions with x within it. But how am I going to solve for x? This just seems like a bit of a mission. Something that is going to help me is relying on the definition of what an arithmetic sequence is. We know that between the terms of an arithmetic sequence, there is a common difference. We are going to rely on the fact that there is a common difference in order to solve for x. Let me show you what I'm talking about on the board. So, between these 2 terms, if I were to calculate the common difference, we know that I can say term 2 minus term 1, and I can say term 3 minus term 2. So if I say term 2 minus term 1, I'm going to have negative 2x minus 3. Then I'm going to subtract term 1, which is 2x plus 4. If I simplify that, I'm going to have negative 2x minus 3 minus 2x minus 4, which can be simplified to negative 4x minus 7. So that's the first difference between the first 2 terms. Now we're going to look at T3 minus T2. I'm going to have 3x minus 1. Then I'm going to subtract term 2. Please make sure that you substitute your term 2 in a bracket. Why a bracket is because I do not want you to make sign mistakes. So we're going to subtract negative 2x minus 3. So I'm going to have 3x minus 1 plus 2x plus 3. So this is going to be equal to 5x plus 2. So we now have 2 expressions that still involve x's. How is this going to help me? Well, I know that it's an arithmetic sequence, which means that the common differences have to be equal to each other. We know that that is the main principle and the foundational concept and rule for arithmetic sequences. So we are going to equate both of the expressions together that express our common difference in terms of x. We know that the common differences have to be equal, so we're going to use that to solve for x. Let's equate them together. So I'm going to say that negative 4x minus 7 has to be equal to 5x plus 2. If you're asking me why, common differences have to be equal. So let's solve for x. If I bring the 5x over to the left-hand side, I'm going to have x. Then if I take positive 7, algebra mistake. If I bring the 5x over to the left-hand side, I'm going to have negative 9x. If I take negative 7 over to the right-hand side, I'm going to have positive 9. In order to isolate for x, I'm going to divide both sides by -9. So that means that x is equal to -1. I hope that everyone's still with me. So the main reason that I could solve for x's was for equating common differences and then solving for x. Let's have a look at the next part of the question. So we now need to determine the formula for the nth term of the sequence now that we know that x is equal to -1. We know that the nth term of the sequence comes in the form of Tn is equal to a plus n minus 1 d. But I don't have a. A is still in terms of x. So what I'm going to do is I'm going to actually substitute in x is equal to -1 to find the value of term 1, term 2, and term 3, as this will help me find d as well as a. So all I'm doing is substituting in the x value that I found into each time or each place where I've got an x, because this is going to help me find the actual values of these terms. So 2 times -1 plus 4 will give me 2. -2 times -1 will give me +2. Minus 3 will give me -1. Then 3 times -1 minus 1 will give me -4. So I've now substituted in my value for x to find the actual values of term 1, term 2, and term 3. Because I now have the actual values of term 1, term 2, and term 3, I'm going to be able to find a and d and determine the nth term for this sequence. Let's work on a and d. So we've already said that the pattern goes 2, -1, -4. I know that a is equal to 2 because a is always equal to the first term of the sequence. I'm now looking for my common difference. We can see that between each of the terms, I've actually subtracted 3. But if I want to write this down in a more mathematical way, I can say that d is equal to t2 minus t1, which is equal to -1 minus 2, which gives me -3. I'm now going to substitute those values into Tn is equal to a plus n minus 1d, as this will help me find the general form of the sequence. So Tn will be equal to 2 plus n minus 1 times -3. If I multiply that out, I'm going to have 2 minus 3n plus 3. So Tn will be equal to 5 minus 3n. Okay, hopefully everyone's still with me. Substituted in the x values to find the first 3 terms. Then I proceeded to find the general nth term as normal. Cool. Everyone, smile. You're doing great. Let's carry on. Let's look at the next question. So we are going to now determine the value of the 11th term of the sequence. Because I'm determining the value of the 11th term, that means I'm going to substitute in n is equal to 11. It's not which term has a value of 11, it is the actual 11th term. So T11 will be equal to 5 minus 3 times 11. So that's going to be equal to 5 minus 33, which is going to give me that term 11 has a value of -28. Wonderful, guys. We are now going to move on to our next question. I hope that everyone's still with me. If you have any questions, please don't hesitate to ask your maths teacher, but please just carry on working with me, following with me, and we're hopefully going to get through this all together. Let's look at the next example. So, we are now told that the sum of the second and the sixth term of an arithmetic sequence is 4. the third term is 24 more than the 11th term. So this is kind of similar to an example we've done in the past where we are given certain pieces of information about a sequence, but we still don't know what the actual nth term of the sequence is. So for this question, we're going to determine what the nth term is. We're going to determine the first 3 terms of the sequence, and we are going to check if negative 72 is a term in the sequence. So for the first part, if I'm saying that the sum of the second and 6th term, the second term would be T2, and the 6th term would be equal to T6. So the sum of T2 and T6 is 4. When I say that the third term is 24 more than the 11th term, that means that T3 minus T11 would have to be equal to 24. Why? Because the third term is 24 more than the 11th term. So everyone, all that I've done is I've written down the sentence, but now I've written it mathematically using Tn values. Let's now replace those Tn values with expressions for A and D. So T2 plus T6 equals 4. We know that T2 can be written as A plus D. T6 can be written as A plus 5D. So all I've done is I've now written T2 and T6 in terms of A and D. If I simplify that, I'm going to have that 2A plus 6D is equal to 4. Now, let's fill in for T3 and T11. T3 is the same thing as A plus 2D. Then I'm going to subtract T11, which is the same thing as A, plus 10D. And that is equal to 24. I'm hoping that at this point, everyone can see that I again have algebraic expressions or algebraic equations that have A and D. Because I have A and D, that means I'm going to be solving simultaneously for A and D. Let's get going with that. So I'm then going to divide everything by 2 on this left-hand side because that's going to give me A plus 3D is equal to 2. So A will be equal to 2 minus 3D. I'm going to substitute that across, but before I substitute it, let me just simplify this side. I'm going to have A plus 2D minus A minus 10D is equal to 24. And actually on this side, guys, we can actually see that our lives are going to be much easier because the A's cancel. So I'm going to have 2D minus 10D is equal to 24. So it's going to be negative 8D is equal to 24, which means that D is equal to negative 3. So I don't even have to take this A across because I know that D is negative 3. I'm going to take this D across to solve for A. So I'm going to have that A is equal to 2 minus 3 times negative 3. So A is going to be equal to 2 plus 9. So A is equal to 11. So if I'm determining an nth term or an nth expression for the sequence, I'm going to have Tn is equal to 11 plus n minus 1 times negative 3. So it's going to be Tn is equal to 11 minus 3n plus 3. So Tn is equal to 14 minus 3n. Let's look at the next question. So we now need to determine the first 3 terms of the sequence. That's found by substituting in n is equal to 1, 2, and 3. I'm going to then see that the first 3 terms are going to be equal to 11, 8, and then 5. So if you substitute in n is equal to 1, 2, 3, I don't have time to show you all the algebra, you'll see that the first three terms of the sequence are 11, 8, and 5. Last but not least, I'm asked if negative 72 is a term in the sequence, and we need to justify our answer. Guys, please remember that when I'm determining whether something is a term in the sequence, I have to actually see if I get a natural number for n. Let's see if we get a natural number for n. So I'm going to substitute in negative 72. And I'm going to isolate and solve for n. So I'm going to say that it's going to be negative, negative 86 is equal to negative 3n. Cool. Then if I divide by 3, let's look at our calculator. Negative 86 divided by negative 3 gives me 86 over 3. But this can't happen in a pattern because I have to have a natural number being a term number. I don't get a fraction value for a term position. So that means that 73 is not a term in this sequence. But otherwise, thank you so much for joining me today. I hope that you guys enjoyed the lesson, and I'm sure I'll see you again soon. Thanks. Bye.